Yeah, hello everyone. My name is Christian Bromann. Thanks everyone really for joining the session. I know that's a really niche topic. I don't know, by show of hands, who have built a VSCode extension? One person. That's great. Maybe after that there will be more, as we know that we can actually test it. Yeah, it's good to be back on the OpenJS World stage. It has been quite some years. A lot of things have changed. I have moved from a company that does testing tool, or that has a testing company, towards a company that builds VSCode extensions. And I still wanted to contribute to my old tools that I've built. I've been maintaining the webviews project, which is a project of the OpenJS Foundation. But I also wanted to contribute to my new ecosystem, which is the VSCode and IDE realm. So I found myself in a position where I could do this, and this kind of talk is about that. So while it is really niche, we still will learn a little bit about the IDE ecosystem, how VSCode is built, and how you would go to test about this, because there's a lot of nifty things that we have to pay attention on. But before we go into that, let's talk a little bit about VSCode. By show of hand, who remembers their first IDE that is not necessarily a text editor? Does anyone remember the first IDE that they've used? There's one, couple. So I believe I started way back in the 2000s sometime with something called webviews, which helped me to build my first web HTML pages. And eventually I moved on to Sublime Text, and then Atom became very popular. But for many years I used VSCode. And I'm sure I'm not the only one. Who of you is using VSCode? The majority. Yeah, that's what I thought. Yeah, VSCode has been shown to be one of the most popular IDEs in the world right now. And not only among us JavaScript engineers, as you can see at the State of JS survey, but also for all kinds of engineers that build software around the world. And there's a number of reasons for that, right? VSCode as an IDE comes with just so many extensions that help you to have the right tooling and the right tooling in place that makes you productive. And it's on top of that really performant. You can install tons of extensions that help you be productive without having any performance problems with the IDE. One of the reasons why it might be performant is it is completely run on web technologies and is using web standards whenever possible. To my taste, it is minimal and very intuitive, and most importantly, also for me, it's open source. Now, some people might think, no, that's not quite true, and actually the VSCode FAQ says, well, it is better to say VSCode is built upon open source rather than it is open source. So we have to differentiate a little bit here. So if you go on the Microsoft product page and download VSCode, that application that you download is in fact a Microsoft product and licensed as such. However, the code that makes VSCode is MIT licensed and available on GitHub. So everyone can go ahead, download the VSCode repository, and bundle it as a vendor-neutral application. And one of the projects that does this, you see it on the right, is a project called VSCodium. They regularly pull the VSCode source code and bundle a vendor-neutral VSCode application that comes without Microsoft-specific components, which is the app telemetry and the connection to the VSCode marketplace. Another project worth highlighting is the Thea project, which is built by the Eclipse Foundation. The Thea project can be more seen as a framework to build your own IDE from scratch. It uses the same component as VSCode does. It has the language server protocol, the extension model, the Monaco editor, so it looks like VSCode, but it is completely rewritten from scratch, just uses similar components. And again, both VSCodium and Thea are independent IDEs, and given that they are not Microsoft product, they don't have access to the VSCode extension, to the marketplace. So where do those people that use those IDEs get their extensions from? So the Eclipse Foundation built an alternative extension registry called the OpenVSX. And the OpenVSX registry can be used by anyone and by any IDEs that have that support the VSCode extension model and that leverage the VSCode APIs. So both registries have about the same amount of extensions available. The most popular ones are available on both. There might be some that are available on one but not the other. But usually extension authors, they publish the extension to both registries to make sure that IDEs that use the VS Code extension model can leverage their extensions. Now, why do I tell you all of this? I think the IDE ecosystem has been growing a lot over the last years. And the way we use IDEs today will be completely different how we use IDEs tomorrow. We see already the move to ephemeral workspaces like GitHub Codespaces or Gitpod. And we also see how much more impactful IDE extension will be for us developers as they help us to just do more things within the IDE. They're much more than just a simple set of auto-suggestions or auto-completions. They play a more integral role in how we as developers do our job. And they're getting more and more complex. We have two examples here. We have GitHub Copilot on the left, which is a VS Code extension where you can write a comment explaining what you want to code, and GitHub Copilot just builds the code for you. It can help you to translate certain code from one language to the other, and can do a lot of more things that are really fascinating. GitHub Copilot basically helps you to connect to a service that has some machine learning algorithm that helps you to translate the code. It's powered on OpenAI Codex, and it's trained on a set of English words and publicly available code, for instance, on GitHub. Another extension on the right, it's called Quokka. It's one of the few extensions that is not publicly available or open source. If you want to use it, you have to purchase a license. But if you purchase the license, it really helps you in your development workflow because it gives you insights into various of things. It helps you test your application better. And it's really worthwhile to purchase a license because the extension does so much for you. Again, all those examples show you, that those extensions get more and more complex, and they help you to do your development tasks in a more automated fashion, give you more insights into problems that you have to solve, and they avoid things like context switching that limit your capability to stay focused. Now, I've been working for a long time now on an extension called Marquee, which does also exactly that. It is one of the first VS Code extension that brings a home screen, an extensible home screen to the VS Code IDE with various widgets that allow you to manage to-dos, snippets, or notes, get weather information, or read hacker news, or just manage workspaces and switch between projects back and forth. To achieve this, Marquee uses webviews within VS Code. So it's a web application built with React that lives within VS Code. It has also a complex state and configuration management, and it allows other extensions to contribute widgets to the dashboard, to the home screen. And all this, shows that not only our applications that we write are getting more complex, but also the tools that we use get more complex, especially VS Code extensions. And here we have to note that VS Code itself is a web application, rendered in an Electron wrapper, and the extension itself within the web view is also just a web application. Both have to adhere to the APIs that its environment provides. VS Code, it's the web APIs, and for the VS Code extension, it would be the VS Code API. And so given that this extension, the Marquee extension, can not only live or run within VS Code as an application, it could also run in a browser when VS Code is run as a browser application. And there are so many factors that can happen that could make our extension break the workflow of the developer, that it would be wild if there would be no chance to test this application thoroughly. So let's talk about testing those kind of applications. Before we do that, let's understand first how VS Code works. VS Code, again, when you use it as a native OS application, it's wrapped within Electron. But it's really just a tiny wrapper because the goal for VS Code is to be run in various environments, not only as an application. You can run it in a browser. You see it in code spaces. I think I just saw yesterday a tweet where someone was running VS Code on their Apple Watch, which is weird, but okay. But the core components of VS Code are mostly the language server protocol, the debug adapter protocol, the Monaco editor, and the extension model. And you can see in orange, the extension itself lives in a different process, which is the reason why VS Code will always still stay very performant, even if you have like 1,000 extensions installed. And so when you build an extension, you define in a package JSON what your extension will contribute to the development experience. And then in a different process, you then implement all these necessary procedures for those kind of contributions to work. We see this here in a small example, and like a hello world example on the right. So basically, when you think about a VS Code extension, it has a package JSON that, again, looks like a normal NPM package JSON, but has some additional VS Code specific properties that, again, tell VS Code where it contributes capabilities to. And then the main object, which references usually to your index file, here references to a file that exports an activate and deactivate method, which are being run by VS Code when VS Code is started and you have the extension installed. So far, so good. Now, when you go to the VS Code API docs, they will tell you that if you want to test your extension, you should use either one of the VS Code test Electron or test web packages. And what those both packages essentially do are they create the VS Code environment for you, and they install, when they start VS Code, they install the extension that you want to test, and they wrap your test code into a test extension. And the test extension, since it is run within the same VS Code runtime, allows you to access the VS Code APIs to trigger certain things to see if your extension reacts to it. So for instance, let's say we take as an example the Prettier extension that you might use. I looked into the Prettier repository, and what they do essentially is they use the VS Code API to create an editor tab. Then they insert some text into it, and then they see if the extension actually reacts to this and reformats the text. And then they just pull the text down and see if the text is formatted. So I would call this some form of integration test. Unit tests are really not much different than other kind of scenarios, but in this kind of example, it's like more like an integration test. However, you can see that the VS Code API kind of like allows some sort of automation, but it really is limited when it comes to a fully end-to-end test scenario, right? So in case, if you remember Marquis, that has a full-blown application as a web view, there's just no way you can use one of those both packages to do some, end-to-end tests in that web view to make sure that your application works. And there's also no chance to take this web view and just serve it as a static website because you miss all the VS Code interfaces that the VS Code API provides. So we need to find something that goes way beyond the integration test level. And as an author of the WebDriver package and a core maintainer, I thought, well, WebDriver can already test all kinds of browser apps. It can test Electron application. It can test on mobile. I've seen tests on TVs, so why not? It is possible to test on VS Code, the VS Code application itself. So I've built a service. WebDriver is built in a way that you can add plugins and reporters. So I built a plugin called the VS Code service, which kind of like allows you to test VS Code extensions by automating VS Code itself. And on the way building that plugin, I've stumbled upon some interesting challenges here. For one, VS Code comes in various flavors. Again, it can be wrapped as within an Electron application. It can become as a browser application. Or again, it can be, your extension can run within Thea or within VS Codium, which are also different kind of environments. They are also all not necessarily the same. Then there's the fact that VS Code is continuously changing. So every time a new release is being made of VSCode, some selectors within VSCode can change and can totally break your test. And additionally, you also want to be able to not only test on the latest stable, but you want to make sure that you look ahead and test on the insiders, which is the upcoming version of VSCode, or be able to test any previous versions of VSCode. So you need to build something that allows you to do this and be flexible enough to test on multiple versions. And lastly, VSCode is complex. So I don't want anyone who's building extension to know a lot about the workbench and all the elements within to be able to write the test for it. So let's look into how those kind of challenges can be solved. First, the idea of VSCode being run in various flavors. Again, here, in order to automate with WebDriver, you have to have a Chrome driver. Chrome driver allows you to send WebDriver commands to it, and the Chrome driver then translate them using the Chrome DevTools protocol to then automate the Chrome browser. Given that the Chrome DevTools protocol, which is the debugging protocol for Chrome, is not backwards compatible, there's one Chrome driver version for the one specific Chrome version. So the difficulty here is to figure out when you test VSCode as an Electron wrapper, which VSCode version has which Chromium version bundled with it, to then be able to set up and download Chrome driver, the right Chrome driver version, to then be able to start the test. So there's some setup issues here that you need to overcome. Second, Electron uses a camel case as parameters, as application parameters, which is a problem because Chromium only understands parameters that are separated by a minus. So Chrome driver will automatically just lowercase those parameters, and then Electron will not understand them. But some of those parameters are really important to inject your extension that you want to test. So the way to work around this is a little bit hacky, but essentially you create a fake binary, and you send to that fake binary only minus separated parameter, and the fake binary just sends then both the minus separated ones and the same ones in camel case. And kind of like starts a new process itself, which is then the Electron application with the right parameters. And lastly, to test VSCode as a web application, it's not just possible to create a static server that then hosts VSCode. There are some APIs necessary that you need to build, and some VSCode extension that you have to inject in order to make this work as well. Next, the continuous changing application. I've looked around into a lot of VSCode extension projects and found that a lot of projects don't test because the selectors change over time. It's the same here. It's mentioned by Don, who's working on the Jupyter extension, saying that whenever VSCode UI changes, the CSS queries have to be updated every time for every release. Those we would end up with one set of tests working for stable but not insiders. So this is a critical problem here. The way how you can solve and go about this is with page objects. If you have heard about page objects in the end-to-end testing world, it's kind of like a way to abstract a website into a class that then helps you to interact with that during your test. So that essentially that you only use a page object within your test rather than working with selectors directly. And so when we create page object for various VSCode components, we would separate those page objects from the selector that we use for those page objects. In this example, you can see that in the blue corner, you can see that for every version there is a locator map defined. So every page object has a locator with a bunch of locators defined. And whenever a new version comes along that has updated locators, you create a new locator file for that new version, you import the previous ones, and then you just update the ones that have changed and re-export them. The WDIO VSCode service now finds out or knows which VSCode you want to test, and it pulls the right locator map and drops them into the page objects. And you can see here that also will help us to get around the complexity of VSCode by giving every component within VSCode a page object. For instance, for the activity bar, for the status bar, for the sidebar, for the editor. So whenever you, as an extension developer, you don't need to know about how VS Code is being set up, what the selectors look like. You have a clear interface of page objects that allow you to interact with VS Code the way you need it. And to make this all work, there are some page object design goals that I put in front of myself that were needed to make this really usable. For one, we need to find a way to easily move the selector map into the page object. For that, we use a decorator here in TypeScript. They are not yet available in native JavaScript, but they will eventually soon. So for now, we have to use TypeScript to get around this. But the decorator that we put in front of every page object class will help us to modify the prototype of the page object to insert some getters based on the selectors that are defined for that specific page object. So the decorator gets the selector map for that page object, and it then adds a set of getters. So whenever you have an instance of that page object, you can directly access the WebDriver.io element to interact with the application. And of course, the getters are a little bit more dynamic. In case they should not only be string selectors. You might want to have function selectors so that you can do fancy things like querying an area label within VS Code by a certain parameter. Then there's this little guardrail that I built also into, which is the object freeze that helps you to protect the prototype to be changed within the test by accident. I've seen that happening out and about, that people just modify the page object to make it work for their use case, but then it breaks other tests. Then there's a base page. You can see in the constructor it takes the locator map. That means that it knows about the locator for the specific VS Code version that it tests. And lastly, there's some TypeScript voodoo necessary to make the amendments to the prototype visible in our IDE when we work with the page objects. So you have to kind of like build an interface that later will be inherited by the page object that allows us to tell TypeScript, hey, this page object class has those getters available, so please don't throw me an error. And lastly, to document something that helped me document all the page object that the service provides in order to interact with the VS Code components. I use TypeDoc to kind of like auto-generate the documentation on all those page objects. And that brings us at the end to something that we can use to do fancy things like this, which is the dancing bear within my VS Code terminal or editor. And you can see on the right the code for that. The important part here is that there is a get workbench command. The browser command is basically the instance that allows you to interact with the application. The get workbench command is added by the VS Code service plugin. And it gives you access to the workbench page object with the right locators for the version that you're testing on. And then from there, you can go on getting the status bar, getting the activity bar, and then go from one page object to another to interact and play with VS Code. So I have a couple of more tests that I want to show you. For that, let me just go back. Okay. Why do I still 2 monitors? No. Yeah, perfect. Okay. Oh, sweet. Okay. So we close this. The first example I want to show is the VS Code live server, which is one of the most downloaded extension in VSCode. It basically allows you to create a static server for your workspace to see the files or the website that you're building. And this is the example for the end-to-end test. Here I'm working with two instances of a browser. I work with the Chrome browser as well as with the VSCode application. What I do then is I dismiss all the notifications that come up at the start that kind of sometimes swallow some other extensions, some other notification. Then I click on this little Go Live button down there. Then I read the notification that comes up with the port that I need to visit. Then with my other browser, I'm going to visit that website and check if the static web server came up. So we're going to just do that. So we start VS Code, and we start the server. Now on the bottom right, you will see the notification popping up for that the server started. Then we take the other instance, open the static server, and see, hey, we can have actually access to the files. That is one example. And the other one I want to quickly show is the marquee example that we have built that helped us now test marquee and make sure that we don't ship any bugs anymore, because that was really crucial to us because we didn't want to disturb developer workflows. And you can see this allows us to finally interact with our web view in the background and do like a whole. There are not many yet because we just finished building the VS Code extension, WDIO plugin, but we're going to build more as we are building more features. With that, I think that's about it. Thank you all for coming, and thank you for paying attention. Thank you.